Hello and welcome to watch this video. This is a first in a series of videos that tell you the basics of how computers work. And in this first video we are going to discuss binary numbers and how they relate to decimal numbers. We will also discuss hexadecimal numbers, and then we are going to study how computer memories work and how they store information. And then we are going to talk about what are bits and what are bytes. So this is the first lesson in a series of lessons, and the ultimate aim of this series of lessons is that you would understand computer technology so much that you would be ready to start learning to program computers. So during these videos we are going to study first some basics, but then we are going to study a very simple computer that is a kind of imaginary computer, and you can find the imaginary computer through this IC8 link at the site naturalprogramming.com. And the naturalprogramming.com, it is my site, and it is meant for people who want to learn computer programming, and there you will find links that contain, or these icons that contain the names of programming languages like C, C++, Java and C# and Python. So through these icons you can find pages that give information about my books about computer programming. And these same things that will be explained in these videos, they are also told in those books. So if you are interested, you can take a look at those pages if you like. But well, we will start with the binary numbers. And in order to study binary numbers, we first must study a little bit the decimal numbers. I think, or I suppose that you already know the decimal numbers, but we will still take a quick look at them. So the decimal numbers, they are such that we have 10 different numerical symbols which we use to make all the numbers, and the 10 numerical symbols are these: 1 or 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are the symbols, and with these numerical symbols we can then construct all the numbers that we need. So if we start counting the numbers or writing down the numbers, we start from 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry, 8 and 9. Now we have used all the 10 numerical symbols that are available in our numbering system. And so when we want to express bigger numbers than 9, then we start using a new column in our numbers. So we put a 1 there, and then we start then we can continue this operation like this, and we can continue it forever if we like. So all numbers can be expressed with these 10 numerical symbols. And And always when we run out of symbols, we start using a new column there, and so we can express very large numbers if we like. The same can be done also with other number of numerical symbols. So we can also do so that we can, if we use the binary numbering system, we use only two numerical symbols, and they are these 0 and 1. 0 and 1. We have only two numerical symbols, but with these numerical symbols we can express numbers in the same way. So if we start counting from 0, 0, 1, so now we ran out of symbols, so we start using a new column there. So we put 1 there, and again we can continue writing down the numbers, but again we ran out of symbols here, so we must start using a new column there, and again we can continue this counting operation, and again we ran out of symbols, so we start using a new column here, like this. And we can and again we ran out of symbols, so we start using a new column there. So, but we can continue. We could also continue this same writing operation here forever, as we can with the 10 symbols. So basically, these two numbering system, the decimal system or the binary system, they are similar. The only difference is that there is a different number of numerical symbols in use. And so these binary numbers, they are very important in computing, and they actually our entire world nowadays is based on these binary numbers. And the secret that why binary numbers are so important is that they can be handled by electricity in computers, or they could be handled also with some other mechanical devices than just electrical devices, but the electronics or electricity has been found the most effective way to build computers that are based on the binary numbers. So that, for instance, inside a computer, it is possible that when there is zero voltage present in a circuit, that would represent 0, and when there is some voltage present, then that could mean 1. So, because there are only two possibilities in the binary numbering system, it is very useful in the world of computers. So we could, for instance, if it is just a decision that, for instance, if we make a decision that, for instance, we wouldn't need to use in the binary system. We wouldn't need to use even these numerical symbols. We could make some. If we would make a decision that the blue dot means 1 and red dot means 0, then we could also express these binary numbers with these two dots. So, for instance, I could draw well, red is 0, blue is 1, so this would be then a red dot, and then I would need to use a blue dot, and here I would need to use a blue dot and a red dot, and then I would need to have blue dots here and here, one blue dot and two red dots, and then blue dot, red dot, blue dot, blue dot, blue dot, and red dot, and then would be again all blue dots. So I could continue it like this, but you can see that the pattern is the same. When there is a 0, there is a red dot. When there is a 1, there is a blue dot. And I could write these numbers also with these dots. It is just that if we make this decision that they are represented like this, we could express numbers like this. And the same can be done inside computers with electronic voltages or electronic currents. So that is the reason why the binary numbering system is used in the world of computing, and we could also study a little bit another numbering system named hexadecimal numbering system. So I have here a table. Well, let's take a look first at this table. Numbers in different numbering systems. So I have here the same numbers that I wrote down there. So I have the decimal numbers. I have the decimal numbers there. I have the binary numbers here. But I have also the hexadecimal numbers there. And the hexadecimal numbers are such that there are altogether 16 different numerical symbols in use. So in addition to these normal numerical symbols that are used in the decimal system, in addition to those, we have symbols A, B, C, D, E, and F. So there are the letters from A to F are also used as numerical symbols in the hexadecimal numbering system. So if I would write it here, so they are the same. So if this is the decimal system and this is the hexadecimal system, so it is exactly the same. Until 9, but then after that comes A, B, C, D, E, and F, and here we will run out of symbols, and then we put 1 there and we start again like this. So if we write these numerical numbers like this, you can see that the decimal number 12, it is C in the hexadecimal system, and it is 1100 in the binary system. Number 5 is the same in both decimal system and the hexadecimal system, and it is 101 in binary system. So that is what this table tells, so that you can find these same numbers there that I wrote down here, and And well, with this binary system and hexadecimal system, I'm using here leading zeros, but they are insignificant in numbers as usual. So why are we then using this kind of hexadecimal system, or these kinds of strange hexadecimal numbers in the world of computing? And the reason for that is that the hexadecimal system and the binary system, they relate to each other in a very nice way. And you can see it, for instance, in this drawing. So here we see that when we must start using a new column of numbers, or when we need to add a new digit to a number, that's the same thing happens in correspondingly in hexadecimal system and the binary system, but not in the decimal system. So the hexadecimal system and the binary system, they relate to each other in a very nice way, and for that reason the hexadecimal numbers are used in computing. So you can see the same thing here if you study this table, that for instance the binary number, when there are 8 ones, that corresponds to the hexadecimal number FF, and there is a change from FF to 100 at the same time, and there is a change from 11111111 to 1 and 8 zeros. That's just an example. So that is the reason why the hexadecimal numbers are very common in the computer world, and it is quite important that you need to master those numbers if you want to become a computer programmer, for instance. On these pages I have also this kind of table here. Important numbers in computing. So so when this binary system is so important in the world of computers, also the binary, or the number 2 raised to the powers of something, they are also very important. And for instance, you can see that here 2 to the powers of 4 is 16, and 2 to the powers of 5 it's 32. So all these decimal numbers, they are always that there is the preceding number, or the following number is always the preceding number multiplied by 2. So all these numbers 1, 2, 4, 8, 16, 32, 64, 128 and so on, they are very important in computing because they are the number 2 raised to the power of something. And here we again can see that the hexadecimal numbering system is quite elegant when we take a look at these numbers. So they are always something full. They are kind of full numbers, so that for instance the 256, it is 100 in the hexadecimal system, and or the 4096 is 1000 in the hexadecimal system. It's also common in the world of computers. It is sometimes common, or in digital electronics it is common to add an H after the number when it is a hexadecimal number. And then in the world of computers we also use this slang thing. Slang thing that we speak about K. K, we say that we can say that there is for instance this 2 to the powers of 17, which is this much, and this much in the hexadecimal system. We say that it is 128k. It is an approximation, but that is how we speak about big numbers in computing. So in this table you can see that, for instance, you might have in your computer, you might have a memory that is 8 gigabytes. That would mean that it has this many bytes of memory, or there would be that much bytes of memory in your computer. So I think after this we can start speaking about the computer memories a little bit. So the computer memories, or we can actually think of these computer memories like this. Or if you say that you have some number of memory in your computer, it means practically that there are some memory cells inside your computer where you can store binary numbers. You can think that the main memory of your computers it looks like this, that there are 8-bit memory cells like this. So you can think that the memory of inside your computer looks like this, and they are each of these things that I draw here, they are 8-bit memory cells. Or we could say that they are memory units. 8-bit memories units which can store one byte of information. So the main memory, you can think that the main memory of your computer looks like this. So in this drawing, in each of these memory cells, so there are 1, 2, 3, 4, 5, 6, 7, 8. In each of these memories units, we can store a binary number that has maximum of 8 digits, or we say 8 bits. So each of these cells can then hold 1 bit of information, and it can be either 0 or 1. So for instance, if I would write, if we would think that this memory location has here it would have these binary digits stored inside the memory unit, then it would contain the number, if we would read it this way, it would contain the number that is, now I have to think in hexadecimal, because this is now 2 and 6. This is 2 and 6 in hexadecimal number. 2 and 6 in hexadecimal number, and I have to check how much it is. So it would be 38 as a decimal number. So this is just an example that if the value 38 would be stored in the computer memory, it would, you can think that it looks like this, that there is this computer memory system, or the main memory, and they have these memory units that can store 1 bytes, and there in 1 byte there would be this binary number stored there. And what is so amazing in computers is that when the main memory works like this, that there are just these memory units, or we can call them memory cells, and so what makes computers so special is that there are so many of these memory cells there. So for instance, if we take a look at an old computer advertisement, so I should have here available some Wikipedia pages. So this first page is about the IBM personal computer, which is these computers doesn't exist anymore, but they are not sold anymore. But that was a very important computer in the history of computing. And here are some technical specifications about this computer. So it says here that it has memory 16 kilobytes, or from 16 kilobytes to 256 kilobytes. So what this practically means is that there is so much, there is for instance, if we take this 16 kilobytes, it means that so there is the 16K. It means that there are this many 16,384, so many of these 8-bit memory cells, or memory units, or whatever I would call it. So that is the secret of computing. So that when we, because we have so many of these memory cells inside the computer where we can store information, we can actually do quite amazing things with computers. And this is just a memory amount of an old computer, so it is quite small. And for instance, if your computer, if it has 8 gigabytes of main memory, it means that there are this many bytes of memory, or there are this many memory cells in your computer that is used by the processor of the computer. So this number, it is so big that I won't try to pronounce it, but it is a very big number. It's 2 to the powers of 33. So this is how computer memory looks, or you can think that computer memory looks like this. It's a very long list of memory cells where you can store bytes or bits or memory where you can store these binary numbers. And in an 8-bit memory cell, you can store the maximum. You can store numbers from 0 to 255. So you can store in one such a cell. You can store these numbers, but computer processors, we will see that they are quite clever, so that they can combine these memory cells so that larger numbers can be stored there if necessary. So in today it is very normal that we have as much as 8 gigabytes of main memory in computer, and in the future perhaps we have even more. But during the early days of computing, there was just maybe something like 16K of main memory. Well, I think this should be enough for the first lesson. So what we have studied here is we studied the binary numbers and how they relate to decimal numbers. We took a look at hexadecimal numbers, and we took a first look at how computer memories store information. And this is also, this term bit is very important here. We store about bits. It is either 1 or 1 or 0, and so there are two possibilities, two possible values for a bit, and a byte is then a memory of 8 bits. So these lessons will continue in other videos, so meet you then in the continuing videos. So thank you and bye.